Hello everyone, this is How I Love Geometry. I'm Mr. Cao. This problem is from 2013 Aime problem number 13. Problem says triangle AB0C0 has side lengths AB0 equals 12, B0C0 equals 17, and C0A equals 25. So I will draw the sketch diagram. Okay, this is 25 and 17. This is 12, right? And it's here is A, B0, C0, right? And this is 12, and this is 17, and this is 25. So for each positive integer n, points Bn, for example, n is 1, B1 and C1 are located on A, B0. So B1, C1, respectively, creating three similar triangles A, B1, C1, similar to triangle B0, C1, C0. Yeah, we can draw the diagram like this way, right? So this is C1, B1, right? So this triangle A, B1, C1, similar to A, B0, C0, and this triangle C1, B0, C0, also similar to the larger triangle A, B0, C0. Okay. Then we just go on, right? So let's go ahead. Forever. Yeah. So, and this is C2, B2, C3, and B3. Yes. And it let us to find the area of the union of all triangles. For here, the first one is B0, C1, B1, this one, and this one, and this one, right? And forever. Yeah. So we know this problem, yeah, at the first glance. We just want to find the sum of these small triangles. And the first idea we will got is an infinite sequence to find the sum of them. And here we know is the similar triangles. So it's this all of this the area is a geometry sequence, right? And we want to find the sum of them. We should find the common ratio. And how to find the common ratio for this triangle? We know this triangle is similar to the large one, and this is the angle C0, right? Yeah, no problem for this one. And this triangle, so this angle, right, will equals to angle A, and this angle congruent to this, right? Congruent to this. And it's similar. It tells us triangle A, B1, C1, triangle similar to the larger one. So this line, this side, parallel to this side. Of course, we will know all of them. So they are similar now. And how to, we know the area ratio of a similar triangles equals the corresponding side ratio squared. So if we just find the first area of this triangle B1, B0, C1, and we find the ratio, the second, I mean this triangle to the area to this triangle A, B, 0, C, 0, and then we just times this area, we will find this area, and so we can use the geometry sequence to find the sum of them. Yeah, regularly the common ratio will be less than 1. For this example, it's obviously it's less than 1. So then we can find the sum because this sequence converge, right? Okay. And so first step, so I mean the idea is easy. Now I think the calculation may be a little complicated, and so you should pay more attention to watch how I do the calculation. Okay, first we want to find the area of A, B, 0, C, 0, right? And we know Heron formula, right? So we should got S equals 1/2. It means 1/2 the parameter. So 12 plus 17 plus 25. So 29. And the 25, 29, 25, half of them is 27, right? So the area of this is S 27 times S minus A 15 and minus B, so is 12, and minus C here is 25, so 27 is 2. And we know the area is, this is 3 times 3 times 3, that's 27, and 15, 3 times 5, that's 15, times 12 is 2 times 2 times 3, then times 2. So how many 3? 1, 2, 3, 4 times, oh no, here is 10, because 27 minus 17 is 10, so that's 15 times 5. No, this 3, so that's the final 2, that's 10, that's so 1, 2, 3, 4, so it's 3 squared, 1, 2, 3, and 2, 5 times 5 times 2, 2, so it's 90, right? Now we got the area of the large one is 90. Then we should find this area, B1, B0, C1, but we have no information about B0, C1, and C1 to B1, but we can use the problem giving information. This one is similar to the whole triangle, and this is also similar to the whole triangle, so we can find some information, because this side and this side, the sum of them is 25. So if I got this side, C0, C1, let us say is X, at first we should find this X, and if we find X, then we will find AC1, and we will find the ratio of the similar triangles. The left will be this one, right? Total is 90. So according to the similar triangle, we just analyzed this angle C0 is they are the same, and this one is to the same one of angle A, and this angle is corresponding is to C0, B0A. Now we can find, if we write the angle C0A, let's write B0 first, right? C0, B0, and C1. And similar to this triangle, this angle C0, now the second one is this, and the corresponding is A, and finally is C1. Then we will got, because they are similar, so we wanted to find C0, C1, C0, C1, C0, C1, C0, C1 corresponding. This is C0, C1, then what's C0 and A, oh sorry, this is B0, that's the large one, C0, A, and B0. So we will got C0, B0. And finally, second, if we use B0C, B0C1, B0C1, we don't know how long for that, but we know C0, B0, right? The first one and the two, C0, B0, so C0A, right? Then we will got C0, C1 equals C0, B0, C0, B0 squared, right? C0, B0 squared over C0A. So it's C0, B0 is 17 squared, and COA is 25. So we got 289 over 25. So we find x. Now we find that's x, right? That's x. 289 over 25. That's x. Then we should go ahead for the next. We have a lot of calculations, right? Here, we have a lot of calculations. So next step we got AC1. AC1 equals total is 25 minus this x is 289 over 25. So equals 25, the denominator 625, 25 times 25 minus 289, so equals, if it's minus 300, it will 325 plus this 11, 336, right, over 25. So we know the length of AC1, and by the way, we can get the area of the ratio of this one, A B1, C1, this area, right? Because next we will use this area to the largest one, A, B0, C0. We just find the common ratio of the geometric sequence, right? The last step, second step will be this, and we want to find the area of this one, right? We want to find the ratio of this two. So that's is the same of we just want to find the common ratio. So it's AC1. So that's the ratio between them is this side square, right? 25, and the total side is over 25. Then that's the ratio of the corresponding sides. The area ratio is corresponding, so it's 360 over. Okay, we just put it this key information here, and then we will go back for how much for this. The first is B1, B0, C1 equals total is 90, right? Total is 90. We got here 90, and we use 1 minus the ratio of this part and the ratio of this part. So I mean we will write this 289 of 25 squared, right? That's this is side, that's the side length, and yeah, this we should over 25, right? Here, over 25. Yes, that's the length of x, and that's the total length. That's the length ratio. That's squared. That's the area ratio. 1 minus this, like this, times 90 minus this area. And also we should minus that x, another one is over. This is numerator. That's the total. Right? Yes, that's it. Huh? So we can do a little simplify, not a total of them. We just times 1 minus that's 625, 289. That's squared. Here is squared. Also minus squared 336 squared, right? Yes. And now we can do something like 90 times squared minus 336 squared. Yeah, we can put them together first. Okay, that's the area of this. Regularly, we can write down like this one. So the total area, what we want to know, to get this one, from the first, this is 90 times and minus 9, right? And this one times, the first one is 1 times this, is the area of this one. And this, the second one, so the second one will get the over, that's the common ratio. And the next one, I mean this one, it will be then, and go on and on. We know the sum of this geometric sequence, right? So the total area, so equals this one. I mean, that's what we want to know. This all of this small shaded, the area is like this way. We can use 90 times, we can use 625 plus, right? We can use times 625 minus, right? Minus 289 squared. And this we know the square, the formula is 1 over 1 minus common ratio, right? That's squared, and here is the square. Okay, then we can go ahead. Yeah, we can know 90 times, that's 961 times 289, right? Minus 289 squared, and 625 squared. And this part, we know all of them. This one 625, then on the top, and here is 625 squared minus 336 squared, right? Okay, we can cancel this one and this one, so it's 90 and times 961 times 289 minus 289 squared. And this one we do the same thing like here, what we did, right? is 961 times 289, correct? A plus B times A minus B. So we will cancel which one? We will cancel this 289. And here got another 289 and 289. Now we know that we will got 90 times 961 minus 961 minus 289. So minus 300 is 661. 600 plus 11, 72 over and 961. So finally we should make sure they have no, or if they have the common factors for 90 and this one. So we will got 90, we can use 2 times 45. 45 is 3 times 3 times 5, right? 9, 10, 90. And this one, 672, we can use 32 divided by 2, 64, then 32, 21. So 32 is 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. 21 is 3 times 7, right? That's this, that's this. Now we just find 961, no 2, no factor 2, no factor 3, because this is multiple of 3, multiple of 3, this one is not. So not multiple of 5, right? Here, no 2, no 3, no 3, no 5, no 2, 2, 2, 2, no 3. Now we just make sure is 961 is the multiple of 7 or not. 1 is 726, we use 3. So 21, 51 is not the multiple of 7, so no 7. That's, we know m over n, so n is 996, 961. That's the final answer, done, 961, okay? Yeah, 961, that's the final answer, but done, we got it. And this problem, I don't think is hard, but is a little complicated for calculation. And I think we can learn how to watch my video, and you will know sometimes to calculation we are not need in the process to got the every result. We can just keep left them here. Finally we can cancel most of them, and the calculation finally, if you pay more attention, you will not mistake, and it will not so complicated. Okay, I hope you can enjoy it. Bye. Thank you.